Hello again, Year 10. This is lesson 5 in the Forces in Balance GCSE topic. And today we're going to be looking at so-called resolution of forces. Please note this is for higher level students only. If you are doing the combined course, then it's pages 108, 109. If you're doing the separate physics, then it's page 130, 131 on the online textbook. Okay, so what you're going to be learning today, you should, by the end of the lesson, be able to recall that resolving forces is the exact opposite of adding forces together. You should be able to resolve a single force into two components that are at right angles to each other. Okay, we're going to start off by looking at a practical example which you've probably seen, but not really thought about how it works. So why is it easier to use a ramp rather than lift something directly? Well, if you look at the picture closely, you can see that the boy here is lifting a rock. When he's lifting that rock, he's working directly against the force of gravity. It's the force of gravity vertically down. He's having to work against that force of gravity. So the full force of the weight is pushing down on him. He only has to lift it a relatively short distance, but he's having to overcome the whole weight of the block. The girl, on the other hand, is sliding the rock up the ramp. Now, if you look at the blue arrow here, this is the weight acting vertically down. And can you see that we've split that single weight force into two other forces, which we call components? And the ones that you're going to be asked to deal with on your course are always at right angles to one another. So if you look at this force here, we've got a force going down the ramp and then a force going at that angle there. Together, adding them together equals the weight. But notice the girl this time is working against the component of the weight down the slope. She's not having to work against the full size of the weight. Now, the offset of that, however, she's applying a smaller force, but she has to move that force through a greater distance. So that's the sort of trade-off, if you like. It takes less effort, less force for her to move that block, but she has to do it over a longer period of time. So the point from this you should gain is that a single force can be split into two smaller forces, which when added together make the original force. And as I say, those forces or components, we're going to call them now, are usually at right angles to one another. In your notes, can you put the title Resolving Vectors into Components? And everything on this slide needs to go into your notes. It's the red little note there. You can, of course, print this off. I've no problem with you doing that, as long as you've got it orderly stuck into your book and you can easily refer to it. Okay, so as we've just said, the components of a force F are two forces, usually perpendicular to each other, which when added together combine to make a force F. So there's our force F. That is our horizontal. The little H here tells us it's horizontal. It's our horizontal component. And then we have a vertical component, FV, like so. And again, you should note that force F can be replaced by doing that and then doing that. Those are the two components of the larger force F. To calculate that force, we could draw scale diagrams again, or today again we're going to use some simple trigonometry, which hopefully you're familiar with from your maths. So if we wanted to calculate the vertical component of that force, we've got a right angled triangle here. Mathematically, the vertical component is given by FV equals F sine, because this is opposite the angle theta that we've got here. So theta is the angle between the force and the horizontal there. So if you've got a situation like that, you can calculate the vertical component using FV equals F sine theta. Likewise, the horizontal component is given by FH, force horizontal, F multiplied by the cos of theta, because this is adjacent to the angle. Okay. And as I say, if you're not really confident in the exam with using your trig like that, they will give you the option of drawing a scale diagram, okay? But it would be extremely useful if you can actually get to grips with this. Okay, let's move on and do a few simple practice questions. once again, I'd like you to have a record of these in your exercise book so that you can refer to them at a later date. So what I'd like to do is, using trigonometry, find the vertical and horizontal components of the following forces, remembering that the vertical component, FV, is equal to F sine theta, and the horizontal component is given by FH, which is equal to F cos theta. So here we go. You might like to pause the video now so that you can draw and calculate those unknown components. Okay, let's see how you did then. The first one here, neat little trick. Once you've worked out the vertical component, the horizontal component will be the same because it's an angle of 45 degrees. So both should be 14.1. Number 2, 5 newtons for the vertical, 8.7 for the horizontal. Number 3, you'll notice that there is a vertical component, it's 15 newtons, but there is no horizontal component. Okay, so that's a nice easy one. And then the last one, number 4, FV is 26.0 newtons and force horizontal is 15.0 newtons. Okay, so let's have a look what a real science question might look like, a real physics question might look like. Again, for your notes, put the title practice question, make a copy of the problem. It's similar to the thing that we started the lesson with. And all I want you to do is to calculate the component of the weight which is acting down the slope. So there's the weight, that's the component that we're after, and the angle of the slope is 30, so this little angle is here. So just apply the rules that we learned a few moments ago, see if you can work out what that component is down the slope. Okay, if you'd like to pause the video now so that you can go through the solution, or we can go through the solution in a moment. Right, the first thing to realise is that the component we're looking for is opposite the angle theta. Okay, so this component therefore is going to be given by F equals W, the weight, the hypotenuse of the triangle, sine theta. It's opposite the angle, so it's sine. So the weight is 200, sine 30 is 0.5. So the girl would have to employ a force of 100 newtons to move that block up to the top there, where the boy has to employ a force of 200 newtons. And again, remember the trade-off is that she's having to push it literally twice as far to achieve that. Okay, then hopefully you've learned the following. You should be able to recall that a single force can be broken down into two components, and for us that's normally going to be at right angles to one another. You should be able to calculate the horizontal and vertical components of a force using F horizontal is F cos theta. To calculate the vertical component, Fv equals F sine theta, where theta is the angle between the force and the horizontal, as we've done in all our examples so far. Hope that's clear. See you next time.